This is Euclid Book 3, proposition number 20. And we're going to start with a circle here, and we have point D way up here, and we have point A down here, and we have point G down here, and a point B down here, so that makes a humongous circle. Okay, and then Euclid says, I want you to draw two angles. He wants you to draw an angle. Now, first of all, you have to find the center of this circle, which is at point E. Okay, and we already know how to do that by Book 3, proposition number 1. So you find the center of the circle, and then you draw a line out from E to C and E to B. Obviously, these two lines are going to be equal because already I have a circle are equal. Okay, so we now have an angle, and it goes from C to E to B. And then Euclid wants you to draw yet another angle. And he wants you to start at point C, he wants you to bring it to point A, and then he wants you to bring it to point B. So BAC is the other angle. Okay? And then Euclid says that angle BEC, okay, so BEC right there, is going to be twice the size of BAC. So here's B, here's A, here's C. So the number of degrees in BEC is going to be twice that of BAC. Now, how are we going to prove all this? Well, we're going to have to draw some more lines. And we got a line from E to D and a line from E to G. Obviously, these two lines are going to be equal in size. We're going to have a line here that's going to be drawn from D to C, and another line that's going to go from D to B. D to C is one of the two lines, D to B is another one of the lines. Okay? And then we're going to have this great big line that's going to be drawn from point A to point F. Now we have all the lines we need to prove that there are more degrees between EC and EB, which are the two rays of angle BEC. There's more degree angles between here than there is between AC and AB, which are the two rays of angle CAB. Okay? Now, how are we going to prove all this? Well, obviously, EA here and EB here are radii of a circle. And if they're radii of a circle, they're going to be equal to each other. The length of EA and the length of EB is equal. And that means that angle EAB and EBA are equal in size. Well, here's E, here's A, here's B, and here's E, and here's B, and here's A. And both of these angles are going to be equal in size because the length of EA and the length of EB are equal in size. And we can prove this by Euclid Book 1, proposition number 5. So we can say that the number of degrees inside angle EAB plus the number of degrees in the angle EBA is equal to twice that. So if you were to take the number of degrees in EAB, multiply it by 2, you would get the sum of the number of degrees in EAB and EBA. Well, here's EAB, there's that angle right there. And here's EBA, here's that angle right there. And if you were to add the number of degrees in these two angles right here, you would get twice the number of degrees in EAB. So twice this is these two right here. Okay. Now, we also know that angle BEF, well, here is B, here is E, here is F, okay, BEF, is the number of degrees in this angle right here is equal to EAB plus EBA. Well, here's EAB and here's EBA, and we can prove this by Euclid Book 1, proposition number 32. Therefore, the number of degrees of BEF is twice that of BAE, right here. All right. Now we go on. EA equals EC. Well, here's EA here, and here's EC right here. They come from the center, they go to the circumference, so therefore they are radii of a circle. And if they're all radii of a circle, they are equal. Okay, already I have a circle are equal, so EA and EC are equal in length. Boom. Alright, now we could also say that angle EAC is equal to angle ECA. Well, here's EAC, that would be this angle right here, and here's ECA, and there's that angle right here. Now, because we can say that, then if we were to take the number of degrees in EAC, well, here's E, and here's A, and here's C. If we were to take the number of degrees in here, multiply it by 2, we would get the sum of EAC and ECA. And the reason for that, again, is by Euclid Book 1, proposition number 5. Now, we're going to go to angle FEC. FEC. There's FEC right there. And we're going to say that the sum of these two angles right here, the number of degrees of both of these angles right here added together, would be the sum of this angle right here. And we can prove this by Euclid Book 1, proposition number 32. So we can then go on to say that angle FEC right here, is twice the number of degrees of EAC. Well, here's E, here's A, and here's C. So this angle right here is twice the number of degrees as this angle right here. Now, we've already established the angle BEC is twice that of BAC. Well, here's B, here's A, and here's BAC. Okay? And the reason why we can say this, alright, is because if this right here is twice of these two, and this right here is twice of these two, okay? Also, we're saying twice of this is this, twice of this is this, then basically we can say that BEC is twice the size of BAC. But we can go on and on and on with this proof, and we're going to. So, this proof is not yet over. I will tell you more in a future video. Stay tuned.